Okay, so let's review and practice how to solve an algebra work word problem. Now, some of you might be saying, hey, Miss D2 Math Man, what exactly is an algebra work word problem? Well, that's a great question. And these problems deal with work or some sort of job that has to get done. And they sound a little bit like this. So maybe there's person A or machine A that can do this work or job in this amount of time. Then there's person B or machine B that can do the same job in this other amount of time. How long will it take if they work together? All right, so if you come across a problem that sounds a little bit like that, well, you're likely dealing with an algebra work word problem, which means you need to understand this formula right here. Okay, so the time it takes people or machines to do a job together is going to be equal to 1 over the time it takes one person or one machine to do that job, plus 1 over the time it takes another person or another machine to do the same job. And this can continue on with how many people or machines that are in the problem. Okay, so you definitely need to be able to use this formula. And what you want to do is plug in the information in the problem into this formula, and then you need to solve the remaining rational equation. All right, so these are a little bit difficult for students in algebra to solve these types of problems. But if you understand this formula and you know how to solve a rational equation, well, you'll definitely be okay. All right, so we're going to practice these problems with these two examples right now. So maybe you want to write this formula down and see if you can solve these problems on your own. Okay, so let's go ahead and get into these problems right now. So many algebra word problems are not too difficult to solve, but this particular type of problem and this specific problem right here will challenge even the strongest of algebra students. But I don't want to kind of build this up too much because I want to give you a full opportunity for you to figure this out on your own. And the problem seems pretty simple, but the solution is a little bit, it might surprise you. Okay, it's not as straightforward as you may think. But let me go ahead and read the prompt to you. It is Dan can dig a hole in 50 minutes. John can do the same job in 40 minutes. How long will it take them if they work together? All right, so again, a pretty straightforward type of problem, at least the concept, right? Where we have Dan working, or Dan could do the job in 50 minutes. John could do the job in 40 minutes. They kind of talk to one another. Hey, let's just work together as a team. They should save a lot of time. So how much time will it take them? That is the question. Okay, so if you could figure this out, go ahead and put your answer into the comment section. I'll show you the right answer in just 1 second, and then of course I'm going to thoroughly go over what's going on in this particular problem, and the solution might surprise a lot of you. Now, again, this problem seems fairly straightforward, but it involves a particular kind of approach. Okay, and this is really important for those of you out there that are learning algebra or want to learn algebra. But before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And it really is my true passion to try to make learning math as easy as possible. So if you need assistance in mathematics, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, don't forget to like and subscribe, as that definitely helps me out. Okay, now one last thing before I show you the answer, okay? Let's just kind of apply some common sense here, okay? So Dan digs his hole in 50 minutes. John's, obviously a little bit faster. He can do it in 40 minutes. So together they should, save a good amount of time if they're working together, right? Or like, hey, you work over here, I'll work over here. They should save a good amount of time. So, you might want to just guesstimate, right? What would be a common sense answer? What would you expect? Now, you don't have to have any kind of mathematical, way to get your guesstimate, but it should be a lot quicker than 50 or 40 minutes, right? Obviously, if they're working together as a team. So let me go and show you the answer. The correct answer is approximately 22.2 minutes. Okay. Now, before I kind of congratulate those of you that figured this out, Some of you might have said, well, maybe it's 45 minutes, right? Because you went, well, let's see here. Dan could do it in 50 minutes, and then John could do it in 40 minutes. Maybe it's the average, right? So 50 plus 40 is 90. 90 divided by 2 is 45. But does that make sense? Okay, I mean, think about it. You have two people. If one person could do the job in, 50 minutes, two people, okay, and they're not too separate in terms of how fast they could do the job. Will it take them 45 minutes? No, they should save a lot more time, right? Working together as a team. So, one thing that you want to do when it comes to math problems is if you do something and the answer just doesn't really kind of pass the common sense test, then, you probably want to look for a different approach. But if you got 22.2 minutes, okay, around something around this decimal right here, that is very, very impressive. Matter of fact, I must give you a happy face, an A++, a 1000% multiple. Matter of fact, I'm just going to stop right there. And I'm going to say, you know what, go home for the rest of the year. You get an A++. Go enjoy, doing whatever you want to do, video games, watching sports. You clearly are a math genius, okay? And you, of course, would say, well, no, I just watch this guy on YouTube. He really helps me out. But listen, this is outstanding if you figure this out. And this type of problem is a problem that you need to understand if you want to be successful in algebra, okay, especially algebra word problems. And we're talking about what we call work, okay, algebra work word problems, okay? So there is a specific kind of formula that we need to understand in order to do this. So if you struggle with this problem, please don't feel bad. A lot of people do, even the best of math students. So let's go ahead and get into it right now. But the first thing we want to do is recognize that we are dealing with a word problem. So read the thing at least 3 times, okay? Just don't read a problem once and then just start doing stuff. That's like a recipe for disaster. So read it at least 3 times. Make sure you understand the question. And then we want to kind of model this situation, okay? But here, again, we want to recognize that we are dealing with the concept of work, okay? And not only that, we're dealing with the concept of one person. We got a person 1 over here doing some work, and then person 2 over here can do this, do a job, right? Work to complete a job. This person could do it in this speed, and this person can do it this speed. And by the way, this also applies to work problems where there's, let's say, machines involved. Okay, one machine can do, produce X amount of widgets, and at this time or this particular rate, and this machine can do this. So you kind of have to recognize these type of problems. But anyways, how much time will it take them if they work together? Okay, well, again, you have to recognize this as a work problem, and you need to understand a basic formula. Okay, so when it comes to algebra work word problems, this is the basic concept that you want to remember. Okay, all right, so what you're going to have is the following. So let's take 2 people. Okay, so if person 1 can do a job in whatever time, and person 2 can do one job in a different time, how much time it will take them working together is going to follow this equation, okay, this formula. So what you're going to do is going to go 1 over the time it takes person 1 to do the job plus 1 over the time it takes person 2 to do the job. Now, if there was person 3 involved, we just had that 1 over person 3, etc. And that's going to be equal to 1 over the amount of time it takes them jointly. Okay, if they're working together, it's going to follow this formula here, 1 over how much time it takes them together. Okay, so this is the formula that you need to understand. And if you didn't understand this formula, of course, it will be kind of confusing, because really what we're trying to think about here is that the concept of 1, okay, this is completing one job. Okay, so for example, Dan can complete one job of digging a hole in X amount of time, okay, and John can complete one job of digging a hole in this amount of time. Okay, so you want to think in those terms, and together they'll be able to complete one job together in this amount of time. All right, so if you're still confused, well, you won't be, hopefully, too much longer, because we're going to get into the actual algebra right now. But again, you need to understand the formula. Okay, so here is our problem. And again, we want to kind of pull the specific information so Dan can dig a hole in 50 minutes and John can do the same job in 40 minutes. So we want to figure out, obviously, what amount of time it will take them to do this together. So this is an algebra problem, so let's assign a variable x, okay, that will represent the time it will take them working together as a team. So we'll just kind of delineate this information this way. So Dan can do this job in 50 minutes, John in 40 minutes, and we'll let X equal the time together. Of course, that'll be in units of measure of minutes. And you do have to be mindful of units of measure because let's suppose I said John could do the job here in 1 hour and 10 minutes, right? So if that was the case, you would have to convert this unit of measure to 60 plus another 10 minutes. So this would be 70 minutes. So again, other kind of twists and turns that you could find yourself in problems. But anytime you're dealing with a word problem or a math problem that involves any units of measure, whether that be minutes, time, distance, it doesn't make a difference. You got to make sure you're working in the same units of measure. Okay, so now what we're going to do is we're going to set up our little formula here, okay? So 1 over 50 would represent Dan, okay? He can complete one job, all right? Complete that one task in 50 minutes. John can complete that one task in 40 minutes, and together they can complete that one task, in X amount of minutes. So what we've done here is translated this situation into a lovely algebra equation. Okay, so at this point, really it comes down to, do you have the algebra skills to solve this equation? By the way, if you are a little bit kind of overwhelmed, you're like, oh boy, this algebra stuff is really, intimidating. Don't let algebra intimidate you. There's just a lot to learn, a lot of skills. I have a huge amount of additional videos on my YouTube channel that can help you out. Also, if you want my full instruction in algebra, algebra 1, algebra 2, whatever the case is, I'll leave links to all my main courses in the description below. Okay, but what we're going to do next is have you subscribe to my channel if you have not yet subscribed. And if you're going to do that, make sure to hit that notification button. This helps me big time. What it does is grow my classroom, my virtual classroom. I'm trying to pack in as many people that are interested in learning math or maybe are struggling with math. My biggest thing, and I'm really passionate about this, is trying to find people who have math phobia or math anxiety or math doubt, like, oh, can I learn this stuff? I have heard through the decades many, too many sad stories on people who said, I gave up on my dreams of being an engineer because some math teacher told me I was bad at math or I failed a math class and no one, gave me the encouragement to keep going. Listen, I'm telling you, you can learn math, you can be great at math. What you need is great math instruction, a lot of encouragement, and strong work ethic. You got to be able to put in the work and practice. But if you got all that together, you can go very, very far in mathematics. But anyways, thank you so much. I hope you do subscribe. And now back to the problem. Okay, so here's the equation. We have 1 over 50 plus 1 over 40 is equal to 1 over x. We would classify this type of equation as a rational equation. It involves fractions. That word rational means fractions. So how can we solve this equation? Well, there's a few different approaches. I'm going to suggest the easiest approach here is just to find the LCD, okay, of the fraction. So we have 50 over 40 equals 1 over x. Now, this is the LCD of these two things here, but I can multiply the equation, everything, by whatever I want, okay? When you have an equation, let's say like 2x is equal to 10, I can pretty much multiply both sides of the equation by any number that I want. It's not going to break the equation. But if I multiply the equation by the LCD of these numbers here, what's going to end up happening is I'm going to clear these fractions, okay? So 50 and 40, the lowest common denominator there is 200. So let's go and multiply the entire equation by 200 to just kind of get rid of these fractions. Now, another approach you could have taken is, well, I could just add these fractions up. That's perfectly fine as well, but it kind of, just been another route to get to the same destination. Okay, so let's go and do that. So I'm going to take this 200 and I'm going to multiply it by the entire equation, okay, each term in the equation. So 200 times 1 over 50, that's going to be 4, right? So 200 or 200 over 1 is 4, and then 200 times this 1 over 40 is 5, right? So this is, multiplying fractions here. 200 times 1 over 40 is just 200 divided by 40, which is 5. And then 200 times 1 over x is going to be 200 over x, okay? So this is a much simpler equation to work with. Clearly, we can see here we can add these numbers up, 4 and 5. So now let's go ahead and continue on. Okay, so 4 plus 5 is 9. So now our equation is 9 is equal to 200 over x. So we can think of this as a proportion. Okay, two equal fractions. We'll just put this over 1. And to solve this, very, very easy. All we have to do is use the cross product. So when you have two equal fractions, you can just crisscross like this. Let me just make this super clear. If I have the fraction 1/2 and another fraction 5 over 10, these fractions are equal, right? And so what you can do is use the cross product. This is a property of proportions. When you have two equal fractions, you have a proportion. So 10 times 1 is 10, and that's going to be equal to 2 times 5, which is 10. Okay, so just to be abundantly clear about this, this is the cross product. All right, so x times 9 is 9x. 1 times 200 is 200. And now to solve for x, super easy. All I have to do is divide both sides of the equation by 9, and then 200 divided by 9. And feel free to use your calculator. It's going to be approximately 22.2 repeating, but we'll just call it 22.2 minutes, right? Because our units of measure is minutes. And now this makes sense, right? If Don, okay, is over here. Let's say here's the hole, and they've got to dig this hole. Don is like, okay, boy, I can do this in 50 minutes. And John is over here. Well, I could do it in 40 minutes. Okay, let's both, work on this thing. If you take the average, 45 minutes doesn't make sense, right? We're like, well, we should save like half the time. Well, if they're really, by the way, too, what I have to make clear on this as well is these type of problems, and I kind of should have emphasized this in the beginning of this video, but when it comes to work problems, when you are working together jointly, it's kind of assumed that one person, in other words, they don't get in one another's way. Okay, so in other words, Don, for example, is working this section of the hole independently, and John's working this section of the hole. But 22.2 minutes, they're like, wow, that was great. It's excellent working together as a team. And it brings me back to my good old military days. Together, everyone accomplishes more. Team, right? Okay, so with all that being said, all right, if you had a difficult time with this problem, most people probably did, okay? These are not, they're common word problems, but, here's a little tip for those of you out there that want to learn algebra or taking some sort of math class, okay? What you have to really get down when it comes to algebra word problems is just master the certain types of problems. Like a work problem is a certain type. A rate and distance problem is another type of word problem. Mixture problems, that's another type of problem. So if you get these kind of other, and there's other ones, of course, if you get these kind of type of problems down, then when you face these problems, okay, you'll have an awareness of what to do. All right, so of course, all this stuff takes practice. But anyways, hopefully you enjoyed the video. And with all that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day. Okay, so if you like to solve algebra word problems, well, this is a perfect little challenge for you because the type of problem that we're going to be doing here seems to confuse a lot of algebra students. And let me go ahead and read the problem. It is the following. A pump can fill a pool in 10 hours. Another pump can fill it in 15 hours. And the remainder of the question is, how long will it take if both pumps work together? All right, so that is the question. Feel free to use a calculator. But if you can figure this out, go ahead and put your answer into the comments section. I'll show you the correct answer in just 1 second. Then I'm going to show you two ways or two approaches you can use to solve these type of problems in algebra. This is really important stuff, especially for those of you out there that are indeed taking any sort of math course that involves algebra. But before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And if you need assistance in learning mathematics, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, or if you just enjoy this content, make sure to like and subscribe, as that definitely helps me out. Okay, so let's go ahead and just take a look at this problem one more time before I show you the answer. So we have a pump, one pump that can fill a pool in 10 hours. And now we have another pump that can fill the pool in 15 hours. So let me just go ahead and tell you right now, if both of these pumps are working together and you said, well, maybe I'll take the average of these two times, 10 plus 15, take that, add these up, divide by 2. Maybe that's the answer. Well, no, that is not the answer. That wouldn't make sense, right? Because one pump, the faster pump, can fill this pool in 10 hours. So if the slow pump can fill it in 15 hours and both of these are working together, well, it's going to go faster than the 10 hours, right? So that's kind of like common sense. But anyways, the remainder of the question is how long will it take if both of these pumps work together? Well, let's go and take a look at the right answer right now. And the correct answer is 6 hours. Okay, so how did you do? Well, if you got this right, that is excellent. Matter of fact, you're going to get a nice little happy face, an A plus, a 100%, and multiple stars. You could brag to your friends and family that indeed you are a certified professional expert in the area of solving algebra work. Okay, WORK, algebra work word problems. Now, when you study algebra, you typically learn how to solve kind of a variety, very common type of algebra word problems. These would include like rate, time, motion type of problems, mixture problems, problems that involve money or age. These are classic type of problems. And work problems are also very classic. So when you have two or more things working, one thing works at one time, like let's say a machine, another machine works at this rate. If they both work together, or it could be people, what is the time? So again, this is a work algebra, an algebra work word problem. So we kind of have to learn how to solve these type of problems. But the first thing we need to do is just take a look at the problem and make sure we use the rule of three, which is always read a problem at least 3 times before you do anything. Now, I already went through the problem a couple times, but once you read a problem at least a few times, okay, a minimum of 3 times, you understand what the question here. And the question is, how long will it take if both pumps work together? We need to kind of use some common sense, right? So when you're thinking about this, you're like, well, I don't even know how long this is going to take. But if one pump, right, can fill the pool in 10 hours and another one can be 15 hours, if they're working together, we would think that both together, it has to be under 10 hours. So the reason why I do that is it's always a good idea to, don't forget your common sense in terms of what kind of answer you should expect. So if you get an answer like 30 hours, right, you have to question it. Like, that doesn't make any sense, right? So before you even get into a problem, you should have some sense of what you think, is going to be a reasonable range of the answer. It certainly has to be less than 10 hours. Okay, now once we understand the question, what we really need to understand is how to solve algebra word problems. And this can get a little bit confusing. So I'm just going to kind of give you a little bit of a formula here. I'm going to show you another way you can think about these problems. Again, these type of problems tend to confuse students. So if you're a little bit confused, you're not alone. Okay, so here is a general formula. Now, what you can do is basically you have these parts. Okay, so one part of the job. Okay, we're talking about work here, right? So when we do work, we are completing a job. Okay, now completion of a job or a task is usually represented by 1. So now, for example, let me kind of explain this here real quick. So if you did one half of a job and I did another half of the job, together 1/2 plus 1/2, we would have a completed job, and that is represented by 1. Okay, 1 is the total complete job. Now you might be asking yourself, well, why is this crazy formula written like this? Well, this is a pretty good way to model situations algebraically. So here is how it kind of goes. So the time it takes or the rate it takes for one thing, it could be a machine, it could be a person. In this case, it's a pump. That part of the job we can represent as a fraction as 1 over that part. Okay, so this we might be thinking about like say not pull, but pump one, excuse me. Pump one. I kind of messed up my little thing here. And then here, this would be the part that pump two, boy, I can't even speak here. Pump two would do. Okay, so 1 over the time it would take for that second pump. Now together, it would be 1 over that amount of time. So we're going to set up an equation algebraically, and this is actually easier to kind of see in action. Now, this is one approach, if you can remember this formula. Now we have 1 over part 1 plus 1 over part 2. And if there's like, let's say 3 pumps involved, this can kind of continue on. So again, I'm going to show you another approach here in a second, but let's go ahead and solve the problem this way. So what we need to do, here is our lovely problem, is start identifying the parts, the machines or people involved that is going to do this complete job. So we have one pump, okay, we'll call that pump 1. It can do the job in 10 hours. And then we have this other pump, we'll call that pump 2. It can do the job in 15 hours. So we'll say pump 1 is equal to 10 hours, right? That's how long it takes pump 1 to do the job. Pump 2, it takes 15 hours. And let's let x equal the time together. Okay, now over here, in this equation here, this is going to be the time together. So 1 over, this is the time for that first pump, 1 over, this is the time for that second pump, 1 over the x is going to be the time working together. Okay, so let's go to put this all together. So we have 1 over 10, okay, this represents that the part of the job that first pump, the faster pump, is going to do, plus 1 over 15, this is the slower pump, and that's going to equal, okay, this pump and this pump working together, it's going to equal 1 over x, and x represents the total time together. Now again, this is a little bit confusing. I'll show you another way you can kind of structure this in a second. But if you can remember this basic kind of work formula, you can definitely use this directly on all different sorts of algebra work prompts. So now it really comes down to your ability to solve this type of equation right here. So 1 over 10 plus 1 over 15 is equal to 1 over x. So let's go ahead and take the next step right now, which of course is having you quickly subscribe to my YouTube channel. Now I'm going to get back to this problem, but I have to stop and interrupt at this point because I need your support. So, you know, I've been on YouTube for a long, long time. I post pretty much every day. I will continue to post every day unless obviously interrupted to some degree, but it is a priority for me to teach mathematics because I just love helping people learn this subject, okay? But I need your support, and the best way for you to support this channel is just hit that subscribe button, and if you're going to do that, you might as well hit that notification bell as well so you can get my latest videos. Okay, so let's get back to this problem. So here is this equation. We have 1 over 10 plus 1 over 15 is equal to 1 over x. Now, at this point, a lot of students would be, or people would be kind of confused on how to set up the problem. I actually think that that part, just setting up the problem, is a little bit confusing. This right here is an equation that you need to be able to solve in, basic, algebra. Okay, so how do you solve this equation? Well, let's go ahead and go through it right now because obviously we have some fractions. And the best way to solve this type of equation is to multiply the entire thing by the lowest common denominator. Now, this isn't the only way, but it's certainly the easiest way. So let's go ahead and identify the LCD here. So if this was like numeric fractions, 10 and 15, which of course they are, but if this was a 1 over here, the LCD would be 30. But because we have this x, we have to throw in that x right there. So the LCD is 30x. All right, now what we're going to do is multiply the entire equation by the LCD. And when we do that, we're basically going to clear the fractions. This makes our life a lot easier. So let's go and see how that works right now. So 30x times 1 over 10. 10 goes into 33, so we're left with 3x. Again, we got our 3x right there. And then we're going to multiply this 30x. We have to use the distributive property, right? So this is going to get multiplied by everything here. So 30x times 1 over 15. 15 goes into 32, so that gives us 2x right here. And then 30x times 1 over x, the x's cross cancels, that's going to be 30. All right, I'll give you some suggestions here if you don't understand the algebra, how you can improve and learn this stuff. But at this point, we clear the equations and we're left with 3x plus 2x is equal to 30. So now this is super easy to solve. all we need to do is combine like terms. 3x and 2x is 5x. 5x is equal to 30. So all we need to do is divide both sides of the equation by 5. 30 divided by 5 is 6. So x equals 6 hours, right? So that's the time together. Remember, x represents the amount of time together, and because these times are in hours, x is in hours as well. Okay, so again, these problems are a little bit confusing for sure, but let's go and take a look at another way that we can solve this problem. Okay, so what we could do, we could say, well, let's just let x equal the hours both pumps it takes for both pumps working together. So we could say, all right, well, let's do it this way. Remember, we have this concept of one being a completed job. So this pump, okay, whatever hours it takes, this is the faster pump. Okay, so this is going to be the part filled by pump one. So that's going to be X hours, right? So whatever, of course, we know it's going to be 6 hours, right? So the pump's going to run 6 hours, but we don't know this in advance. But this pump is going to run the same amount of times because these pumps are obviously working together, right? So, we're not talking about different times here. We're going to turn on both pumps simultaneously, and they're going to get the job done. Okay, so the X could be the amount of hours that this particular pump that can fill the pool in 10 hours. And then this is the part where this slower pump that can fill the pool in 15 hours. And together they're going to get the job done. And again, remember, when the pool is completely filled, that represents a completed task of one, right? So like you doing one half of the job, or this pump doing one half of the job, and this other pump doing one half of the job. Together, they complete the task, which is one. So remember, this concept of one represents a full completed task or job. Okay, so this is another type of equation. It looks similar to the other one, but it actually is a little bit easier to solve. So x over 10 plus x over 15 is equal to 1. It's a different equation, but it's just as good to solve this problem. So let's go ahead and solve it right now. Okay, so x over 10 plus x over 15 is equal to 1. What is the LCD? This is the best way to solve this. We got 1. The LCD here is 30, right? That's the lowest common denominator. So we could just multiply the entire equation by the LCD. And when we do that, we have 30 times x over 10. So 10 goes into 33. So this is going to be 3 times x, or 3x. Of course, remember, we're using the distributive property here. 15, 30. Let me just not go so quick here. I know a lot of you are maybe saying, slow down, Mr. YouTube Math Man. Okay, so 30 times x over 15. 15 goes into 32, so that's 2x. And now 30 times 1 is 30. All right, so we'll take a look at what we have. We pretty much have the same equation. 3x plus 2x, 5x is equal to 30. Divide both sides of the equation by 5. X is equal to 6. 6 what? Hours, because we define x as the number of hours up here. It would take both pumps working together. Okay, so these are two different approaches to solve work problems. And the only way you're going to get better at solving work problems is to practice, practice, practice. But again, these type of problems tend to confuse a lot of students. They kind of remind me of mixture problems as well. These type of problems, again, are things that you're going to face if you are studying algebra. All right, now just a quick comment on some of the algebra, some of the formulas or equations, excuse me, that we solved here. Those are examples of rational equations in LCD, finding the LCD, etc. So if you need help with this level of algebra, I would direct you towards like my Algebra 1 course. You'll find a link to it in the description below. Now, if you're in Algebra 2, I teach the same material and more, obviously in Algebra 2, in those courses. Now, if you need help with basic fractions, or if you want to kind of learn some basic mathematics and algebra, and you're not just, you're not a math student right now, check out my Math Skills Rebuilder course, because I'll teach you fractions and I'll also teach you a ton of algebra in that course. Now, if you want to do more of these type of problems, more algebra word problems, of course, I teach or I go over a lot of different word problems in my various courses, but I also have a ton more of algebra word problems on my YouTube channel that you can practice with as well. But hopefully this little problem was a nice little challenge, and if you enjoyed this video, don't forget to like and subscribe. And with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time, and have a great day.